our second problem, because the second problem is really is pertinent to what we're going to be doing today. Alright? So we're going to take a closer look at it. And then we're going to talk a little bit about some other things that we use these exponential functions for. A and B you can do on your own. The other one, that's the one that we're looking at.
Which one is that?
The second one. To find the balance.
Oh, you plug in the numbers for X. You don't put X in your calculator. When the X on it, it's negative
Reciprocal.
So it's 3. It's positive 3, right?
Okay.
Yeah, it becomes positive 3.
Mario, you got it.
What you talking about here, bro?
What happened? I'm legally blind.
Who did that, Sierra?
It's like that. What you talking about?
Oh,
Whatever you call me.
Monte did that?
I'm brother phone.
He did that. And what you did? Gorilla Vine.
Thought you knew better.
No, you didn't put that before now because
Putting that on that light skinned girl like that.
Yeah.
That girl light skinned. I do be saying anything.
I'm telling you.
That girl light skinned.
Yeah, you can see it's going over.
Yeah.
The real boy now, is it not? Why you put it up in the first place?
Because I was going to write on it.
Oh, what is
Oh, you might as well leave it down.
Yeah, now that's better. Like, do that one right there,
You can
right
see that?
there.
It look like Star Wars.
The last thing I would have thought of.
Alright, so A and B you can, number one, A and B, you can take care of that. That's we're just basically plugging in. And you're plugging it in twice, so you're plugging in for -3 and for positive 2. Now, what we're going to introduce today is this. One of the ways that they use exponential equations or exponential functions in the real world. You know, and one of the main ways they use it is with your money. So if you wanna invest your money in like stocks or you know, like for some of us who are some of us adults who have 401ks, we invest so that we can get money for retirement and different things like that. They have a way to calculate how much money we'll have later on, depending on the amount of interest. It's also going to come up in some of the daily, some of the things that are the more common things that adults buy, and we're going to talk about a couple of those in a little while. All right. So here we have your bank account. Anybody in here have a bank account? All of y'all got bank account?
No.
Anybody has an interest-bearing bank account? How much percent interest do you get?
10%.
No, you don't get no 10%.
You got checking your savings.
5%.
Both.
Oh, okay, Marley.
Your savings bears interest, it's just not a lot.
Yeah, if you have a 10% interest bearing account, let me know. So I need to put my money there.
Oh, so what is it, 3%?
No, right now the interest rates are about.
I can't have it back.
Right now, interest rates are. Right now, savings account interest rates are about a little bit less than 1%.
What?
All right.
Like 0.5 or something?
It's low
Damn.
because you know banks.
I was
You know
pushing.
that's how banks make their money. They don't want to give you back as much, right? So but in this case, you're getting 2% interest on your account.
Mm-hmm.
So you have $2,000, you put it in the bank, it's giving you 2% annually. All right, meaning that 2% of your money every year is going onto your account. So, and this is going to happen for 10 years. So, one of the things that they do is came up with a formula to say, well, you know, this is how much money you're going to have at the end of those 10 years. So we're going to plug in and we're going to find out how much you're going to have after those 10 years. And like I said before, this is an exponent, right? So that's part of our exponential function. So let's put it in. So our principal is what we put in at the beginning. So that's 2,000. And then we're going to multiply that times 1 plus whatever our interest is. Now our interest has to be in a decimal. And like Diana mentioned earlier, 2% of the decimal is 0.02. And it's compounded quarterly. So you see here, it says quarterly. So how many times does it compound per year? 4. There you go, very good. So that's 4 times. And then we have n times t, which is our, how many times is compounded per year times the number of years?
4 and 10.
4 and 10, so that will give us 40. So once we work this out, we'll find out how much we have at the end of 2 years. So can somebody work that out for me real quick? That times 40 instead of 40 and now.
Real son.
What?
Cross globe. Bitch chose.
What's wrong with you? You'll be mad. You still left that we said like 20 minutes ago when that like thing was living up all that.
That's it. So what you got?
What's wrong?
2 sacks.
Go ahead.
244, 1,
It's 2, 4, 4, 1, 0.58. Or let's say 0.59. All right, so, thank you, Rudy. So, here we go. So, that's what we get after 10 years. After 10 years, we have increased our $2,000 to $2,441.59.
Got 24 plus.
Right. So, in actuality, how much interest you're making on your money is, it will be this minus our $2,000. And that will give us $441.59. So, over 10 years, we have gained $441.59. All right? So, yeah. So this is the amount that we have, that our money has grown to, and this is the amount of interest that we have gained on our money. So over 10 years, you have gained only $441. Alright, so imagine what's going on now with the savings account that you have now that's giving you less than 1% or less. So you're not gaining much money. It's not very profitable for you to actually put your money in the bank in a savings account, only if you want to just save the money. We talk about, we're using exponential functions and some of the common uses of it and their benefits. All right. So we talked about exponential decay. We talked about exponential growth. But in this case, we're going to be talking about how they use it in terms of interest payments and different things like that. So I know everybody in here wants to buy a car, right? At some point, you want to buy a car, right?
Yeah.
So we're gonna try. I'm gonna show you today how you can calculate your interest or your payment, your car payment for every month. All right. Also, I know everybody here wants to buy a house at some point.
Yeah.
Right. So we're gonna try.
I want to do a condo.
We're gonna calculate your mortgage too, and show you how exponential functions are used to calculate all of these things. All right. But first, let's look at a little video. Compound interest and also simple interest. All right, here we go.
Compound interest is the interest an investor earns on his original investment, plus all the interest earned on the interest that has accumulated over time. It is easier to think of compound interest as interest on interest. To understand compound interest, let's first look at simple interest, the interest earned on the original principal only. Suppose you deposit $10,000 into a high-interest savings account at a 5% simple interest rate for 3 years. The interest you earn each year is 5% times $10,000, which equals $500, for a total of $1,500 of interest at the end of year 3. $500 plus $500 plus $500. Now instead...
As far as the 3 years, like for some people that means absolutely nothing to them. Now, so if, as a shady business owner, that this was your deal, that even though I told you I was giving you compound interest, I simply set up my information to give you simple interest. If there's 15 people in here, at least 10 of y'all are not going to catch on at the end of the year when I give you your $1,500. So if I go ahead and I give each one of y'all $1,500, and 10 of y'all was able to go ahead and keep y'all $76, I just made $760 just by you not caring about your $76, or you're not paying attention to what your interest rate is. Banks, you know, these larger companies, they have hundreds of thousands of customers. So if they're able to get away with that, look how much more money it is for them that they get to keep when we don't pay attention to what our money equates to, or what type of money we're supposed to get back.
You should pay attention to it. Why wouldn't you?
Some
That's
don't.
your money.
Some don't.
Shit, I would.
Interested in, and how the difference between, like I just said, between simple interest and compounding interest. All right. So what we're going to do is, like I said, simple interest. We're going to look at interest paid on a car loan and also interest paid on your mortgage or your home. All right. So here's simple interest. So in your notes, you can take this down. So it says simple interest. Simple interest is more of a linear, because we did linear equations before. It's more of a linear equation. Yes, on that. Yeah. Interest paid on the original principal only. And then here is our example. So our example is, you borrow $5,000 at 6% interest for 2 years. How much are you going to pay back? Right? You will pay the $5,000 times the interest, which is in a decimal. Give me 1 second. Which is a decimal times the number of years that you're paying it back, and that's how much interest you're going to pay. You're going to pay $600. So if you borrow $5,000, after 2 years you have to pay back $5,600.
Not even goofy.
And now we have compounding. Compounding interest is more of an exponential function. All right. So compounded interest is interest earned not only on the original principal, but also on all the interest earned previously. So it will take whatever interest you earned in that first year, and then they will find, you'll multiply to find the interest that you have to pay on that total amount for the next year. All right, and I'll show you how it works again, just like in the video. So it's compounded.
To the bathroom.
All right.
Don't change that. I got a pit right there.
So, in other words, at the end of each year, the interest earned is added to the original amount, and the money is reinvested. Same $5,000, we invested it, is compounded every year. So now we have 5,000, same interest rate, 6% times 1.
So that's right what you put.
Yeah, this is an example. So that will give, after 1 year, it will give us 300. Right? The second year, we're going to take that 300, add it to the principal. We're going to get 5,300, and then we're going to find the interest on that for our second year. And our second year payment will be 318. So if you add them up, you'll see that over 2 years, instead of paying back 5,600, now you're paying back $5,618, which is a little bit more. It might not seem significant, but like they said at the end of the video, as time goes on, and depending on the length of your loan, the more interest that you're going to pay later on. It grows exponentially. And remember, we saw that with our exponential functions. Our exponential functions grow really slow at the beginning, and then they pick up and become really steep at the end. So this is why we have things like your mortgage. That's why your mortgage is like 30 years.
It's easy at the end of the day knowing it's not yours.
Yeah, like you have a big event coming up, like it may be only $18, but the greater amount of years that you add on to your loan, the more money that you're going to pay back. Alright, so here's a quick quiz for you. And you can use, hold on, and you can use your notes that we just did. So make sure that you understand that you have an idea of the notes that you just did. Alright?
So what we write this on a separate sheet of paper?
You write this on your lesson highlights. So on this sheet, on the first sheet, this is where you write your lesson highlights. This is where you put your quiz. That's all I want. I just want the number and the answer, A, B, C, or D. All right? There are 4 questions here, the first 2.
Head first, sun down. Miss Alla, can I go to the bathroom, please?
Somebody just went to bed.
That's a boy, though.
That's what girls.
A girl just went to bed.
Write it on your
You write down number one. And
That's
whatever
a
choice you have. Number
So all you're writing is the number 1. You're writing whatever choice. 2, whatever choice. Alright?
I'm trying to see the different.
So take a minute on each of these and
Trying to
then
bury that man.
the second page you have to do some calculations, so it's going to take a little longer. So the difference between simple interest and compound interest is that, and you get your answer.
No.
So take a couple minutes on that.
You invested $1,000, 3 gigs. Head first, sun down.
You only have to write the letter that corresponds with your answer. That's what you choose.
No.
You ain't stupid. You know that.